Hey, OChem Stars, this is Mrs. Vandalay bringing you OChem Star video. I hope you're enjoying your day off, but you still got to do something today. So why don't we go into our pink books and look for this OChem Chapter 1 Bonding and Isomerism notes. This is behind the section that we just did, so it should probably be right before that second pink divider, okay? So if you need to pause this and find where I'm looking or find where I'm at, then go for it and pause this and come back when you're ready. All right, so hopefully you found where we're at. So we're going to start off with something that's familiar, and most of this is going to be familiar. We've covered a lot of this, but you're going to get something new today, okay, I promise. So let's just see what we're going to do. So writing formulas. There are molecular formulas, tells you how many and what kind of atoms are in the structure, but not how. So for example, how about C2H6O? Now, what does that tell you? Well, there are 2 carbons, 6 hydrogens, and 1 oxygen. But what does it not tell you? How it's arranged. So look, this is one way it could be arranged. I'll kind of do it this way. See, here, and then, oh, don't forget your lone pairs. And there is one way to do C2H6O, but watch, there's yet another way. With my lone pairs. And look at the difference, all right? They both have the same exact molecular formula, all right? But this one has the OH, this one has the alcohol in it, all right? So we can talk about his lone dispersion, dipole, and hydrogen bonds. This one is still a polar molecule because remember, this oxygen is bent, but it has lone dispersion and only dipole. These are very, very different structures, all right? Looking at the formula did not tell me which one of these 2 very different compounds I'm talking about. So a structural formula, which we've already talked about, not only shows what elements and how many, but how they're arranged. So these are your structural formulas. They're showing you how they are arranged. And I drew full or expanded structural formulas, okay? So there's another example, and we're going to learn more about this later, actually the next time we meet, on how do I name this stuff, okay? So the prefix pent, you might figure out, means 5, like a pentagon has 5 sides to it. The ending ane tells you they're all single bonds. So if I were to do a structural formula of pentane, all right, I would do this. So I'd write 5 carbons, and now I'm going to add enough hydrogens, right? So that carbon is going to get that magic number of 4 bonds. Always has to have 4 bonds. Remember, it doesn't have to have 4 bonded atoms, but it has to have 4 bonds. All right, and the fact that I already told you they're all single bonds tells you that, all right, this is how it's going to be with all this. It's going to be saturated with hydrogens, okay? Now, I'm going to do another one, all right? So let's start over here. And I'm giving you a preview, but there's a reason. So down below the abbreviate, there's a reason I want to do this. So let's add another one. How about 2-methylbutane? All right, so just kind of go with this for me. So my butane has 4 carbons, and there's a methyl group on the second. So this would be the basic form for 2-methylbutane. But now if I want the expanded structural formulas, then I need to put on the hydrogens so that each carbon will have 4 bonds. So this carbon, whoops, right here is going to have 3 hydrogens. What about this carbon right here? It already has 1, 2, 3 bonds. All right, so it needs 1 more right here. This one has 2 bonds, so I'll add 2 hydrogens. This has 3 hydrogens, and this one has 3 hydrogens. Well, before we go on any further, what do you notice about these 2 structures? 1, 2, 3, 4, 5. How about my H's? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. How about this structure? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Oh, so these have the same molecular formula, different structures. Interesting. Now, what about the abbreviated structural formula. This shows each carbon with hydrogens or other elements. So let's look at this one. So take the look at the very first carbon. Okay, whoops, too far down. Let's take a look at the very first carbon right here. And what's on that first carbon? I have 1, 2, 3 hydrogens. What about this carbon? What's on this carbon? 2 hydrogens. What's on this carbon? 2 hydrogens. What's on this carbon? 2 hydrogens. And what's on this carbon? 3 hydrogens. Okay, watch closely what I do here. What's on this carbon? 3 hydrogens. This is where you got to be careful. What's on this carbon? Well, there's a hydrogen, but what else is on this carbon up here? So I'm going to do a CH3 in parentheses. And if there is a parenthesis here, it's probably going to be a branch. Not always, but probably going to be a branch. Okay, so that's when you have to count to 4. So if I look at this carbon right here, it's bonded to 1 carbon, 1 hydrogen, and then if I wrote CH2 here, then 1 carbon. So I'll say it again. This carbon has 1 carbon here, 1 hydrogen here, and 1 carbon there. So this has to be also attached to that carbon, okay? Because this carbon needs 4 bonds, all right? And then CH3, okay? Well, there's, see that or here? I'll put the or right there. There is yet another abbreviated structural formula. It's an abbreviation of the abbreviated chemical formula or structural formula. So what the heck does that mean? Well, if you see a whole bunch of the same things together, just like this, I see 3 CH2s in a row. I can abbreviate that. So I have CH3. Then I'm going to put in parentheses CH2, and how many of those do I have? 1, 2, 3. I have 3 of those. All right, and then CH3, because this is not identical to this. So this is an abbreviation of the abbreviated structure formula. But what about this? Is there a quick and easy way to do this one? Is anything the same? Well, yes. Do you see this carbon here? What's on this carbon? There's a CH3 here, and there's a CH3 here. I have identical CH3s on this carbon. So I'm going to make this carbon here. Here's my CH, okay? There's that hydrogen. But I'm actually going to precede it with CH3, 2. That means that both of these are on that carbon. And then I have CH2 and CH3. Okay, so that's still an abbreviated structural formula. Okay, so this is your new material, and this is going to take a little bit more practice, all right, to kind of see how this works. So this is the brand new stuff. And let me just kind of give you a little heads up, okay? I'm going to make a little bit more room. So I'm going to do that. Why is this abbreviated structural formula so handy? Well, how about this? That's wax, by the way. All right, so that's wax. And can you imagine doing this 22 times? That's a lot of writing, isn't it? So what could I do? I could do the CH3. I'll do the CH3. And here I'm going to have 20 CH2s. And isn't that a whole lot easier? Oops, 20, sorry. It's a whole lot easier writing it that way than writing CH3, CH2, 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 CH2. It's going to fill up my whole paper if I do that. All right, so this makes it a lot easier. So when you have the really large molecules, this is handier. Okay, let's go on to the next page. You ready? Okay, so what's a line notation? We've already done this. Each line segment is understood to have a carbon atom at its vertex and its endpoint. The H's are omitted but understood. So write the molecular formula and draw each structural formula for 2-pentene. All right, so 2-pentene tells you 5 carbons. There is a double bond because it ends in ene, and 2 is where the double bond is. So I'm going to write, let me draw the first one. So I have 5 carbons. There's my pent. And on the second carbon, I have a double bond. So let's draw the full expanded formula. Therefore, I can figure out what the molecular formula is, all right? So how many bonds are going to be on this? Well, 3 H's, okay? Well, how many bonds are on this one right now? 1, 2, 3. So I need 1 more hydrogen. How many bonds are in this one? 1, 2, 3. So I need 1 more hydrogen. How many bonds are in this one? 2. So I need 2 more hydrogens. And how many bonds are in this one? 1. So I need 3. Okay. So what's my formula? I have 5 carbons. So my molecular formula is C5. Now let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. H10. Okay. Whoop, there you go. All right. So that's my molecular formula. So now what? I need an abbreviated formula. All right, so what's on this carbon? I have CH3. What's on this carbon? CH. What's on this carbon? CH. What's on this carbon? CH2. What's on this carbon? CH3. Okay, so is there anything I can abbreviate it with? I guess so. CH3, CH2, CH2, CH3. All right, so there's that. And now let's do the line notation. All right, I'm going to look at this again. And okay, I need 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And I have a double bond between 2 and 3. So there is all those different kinds for 2-pentene. So write the molecular formula and the full and abbreviated structural formula of this. Okay. Well, I want to do this with you. All right. So I'm going to look at this and come up with the full structure of the formula. So I have 1, 2, 3, 4, 5, and I have a 6th one here. But I'm going to start. This carbon is going to be this carbon. Okay. So I'm going to put a double bond between, see, there's a double bond here and here, and then this carbon has another carbon off of it. All right, so I'm going to put hydrogen and a hydrogen. Why only 2 hydrogens? Because this already has 2 bonds. Now be careful with this one. Is there any hydrogens needed on this carbon here? We'll count 1, 2, 3, 4. Nope. This one needs 3. This one needs 2, 2, and 3. All right. All right, so let's try this. Start here. I'm going to do my abbreviated CH2. What's this one? Does this one have any hydrogens? No, but it has a branch, so put it in parentheses, CH3, CH2, CH2, CH3. Okay. Is there even a more of an abbreviated version? Do you see anything the same in a row? Yeah, I see 2 of these guys, identical. All right, CH2, C, CH3. Now again, if you're going to count your bonds, you're going to see that this already has all 4 bonds, okay, when I make this a branch. So now these 2 are just part of the long chain, and then here's that. Okay, so I think, I did not do the molecular formula, did I? So let's count. 1, 2, 3, 4, 5, 6. There we go. So it's C6. Now let's count our H's. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. H12. So what I would like you to do is take a few minutes out and do number 3 for this one. All right. So do all the different versions, the molecular formula, and all the structure formulas for this. Okay. So pause this, try it. All right, welcome back. Hopefully that worked out for you. So I see I have 5 carbons in a row. And on the 1, 2, 3rd carbon, I have another carbon. Okay, so I'm going to do this. H, H, H. This has 2. How many bonds does this carbon have right now? Has 3. So I need a hydrogen here. This has only 1 bond, so I need hydrogens here, hydrogens here, hydrogens here, and hydrogens there. Okay. So now what? All right, what about my abbreviated? So here, you see where my finger is? That is my CH3. This is my CH2. There's a CH, but what else is on this carbon? It has a branch. Oh. So this is that carbon. They're the same thing. All right. And there you go. So is there an abbreviation of the abbreviated form? The answer is no, not in this case. Why not? Look, is there anything identical? Nope. So there is no abbreviation. And the last thing is the molecular formula. So I have C, 1, 2, 3, 4, 5, 6. H, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And I'm done. Okay, hopefully you got that too. All right, last but not least, this is an abbreviated formula. Okay, so what I want to do is kind of figure out this. Okay, so this is that one. That's this one. Here's the 3rd one. Here's that one. Here's that one. Now look, this carbon is that carbon, okay? So how many bonds does it have? Oh, it has a hydrogen on it. All right, I'll put a hydrogen here. But it has 2 bonds right now, so it needs 2 more bonds. Well, I have CH3s written twice, don't I? And so one of these was a branch, and I did it that way. So now I can do the line segment. Ready? I have 1, 2, 3, 4, 5, 6, 7 in a row. 1, 2, 3, 4, 5, 6, 7 in a row. I have a double bond between the 3rd and the 4th, right here. And here is 4, 5, 6. On the 6th one, I have a branch. 1, 2, 3, 4, 5, 6. I have a branch. So my carbon's right here. All right, and that's it. Okay, so the key to this one is to understand that part. Okay, let's go on to the next page. All right, so now we're going to talk about classification, and we're going to cover all of this in this course. Okay, so the first type is going to be the acyclic compound. So notice it has an A in front of it. So if you ever see an A in front of a word like amoral, I don't know why that came in my head, but it means not moral. All right. So if that A prefix means not, then this means a not cyclic. Not cyclic means a straight or branched structure. They're not in a ring, okay? So they contain single or multiple bonds. There we go. And they can be branched or unbranched as shown. So these would all be acyclic. And this is going to be, we're going to learn how to name these guys in the first or the 2nd chapter, and we're going to know what to do with this one in our 3rd chapter, okay? And it says we'll spend more time practicing. All right, so the next one is 1.3 classification according to functional groups. And you're going to have to memorize these down the road, okay? So about 4th quarter, you're going to need to know this, all right? So hang on, I need to get rid of something. All right, so anyway, we have alkanes, alkenes, alkynes. This is chapter 2. These are chapter 3. Aromatic is chapter 4. Then we're going to do something else after chapter 4. And then after we're done with chapter 6, then we're starting to look about alcohols. Alcohols have an OH. Ethers have an O in the middle. Aldehyde, all right, so this would be ethanol, has a C double bond O with an H. Okay, again, you're going to have to memorize these. I missed one right here. All right, so then your ketone has C double bond O, but the C's in the middle. Carboxylic acid is a C double bond O, OH. And ester has a C double bond O, O carbon. Now, you've seen most of these structures that we drew, but you didn't know what they were. An amine, all right, has a nitrogen in it. An amide has a C double bond O and a nitrogen in it. And then your alkyl halide, all right, has your halide in it, your group 17 in it, okay? And finally, these functional groups are certain, there we go, groups of atoms that have chemical properties that depend only moderately on the molecular framework, the carbon, to which they're attached.